All right, this is a preview, and there's lots to cover. I'm pretty excited. This is going to be included in DragonOS in the next release once everything's all working correctly, and this should allow anybody to do propagation or RF coverage mapping of whatever transmitter that they choose from 20 megahertz up to about 20 gigahertz, I think. So, but a little of the history of how this came to be. We can take a look at Signal Server and Splat, which I have a Signal Server pulled up on the screen here. It's an open source multi-threaded RF coverage calculator based on Splat, which Splat is short for this RF signal propagation loss and terrain analysis tool from 20 megahertz to 20 gigahertz. You can read all about it here, but what caught my attention was years ago, a gentleman by the name of Dr. Bill Walker had created a web interface that allowed an individual to plot their characteristics, their RF characteristics, and generate a KMZ file to overlay onto a map. So that caught my attention, and thankfully, Dr. Bill Walker was really nice enough to take all my questions and release the source of his web interface, as well as help get it updated, which still work to be done, I'm sure. But this is what you see in front of me or in front of you right now on the screen. So we're going to walk through this here. By the time this is all included in DragonOS, the only thing that you'll have to do is include elevation data. So, and we'll go over that here in just a second. But so, what does this really do? Well, I have already plotted some characteristics of a TV tower in Denver, and I've already put it in the database through the enroll. I know it says call sign, but really just think of that call sign as any name that you want, and that'll be adjusted. I mean, this was really kind of meant for ham stations, as you can see here in the registration page, but we're going to tweak that a little bit to allow other types of transmitters to be plotted. But I've already put in a tower here. I just named it KW test, and so I had put some characteristics of its height, and really the frequency would be we can just put 500 to 90 megahertz, and the ERP in watts was about 100. There we go. There we go. And I just come down through. I don't want any other locations plotted for this particular plot that I'm going to do. And you can generate a plot, and what will happen is behind the scenes, the multi-threaded application Splat is running with these particular characteristics to generate a plot. Now, Signal Server can be run via the terminal command line, and there's many more settings that are available, which is all talked about under the parameters section of Signal Server. But to make this easy, we can use this interface, which you can see here generates a coverage map. Now, these colors mean different things, which will eventually I'll get a legend into here, which is actually shown on the Splat page. If you read down through and look at some of the examples that are possible with this, you can see somewhere here, there it is. So there's a legend on these colors as you go out from the transmitter. Of course, the power levels are changing and most likely decreasing. So now we have this KML KMZ file that we can download, which I've already done, and then we can open it in Google Earth. So this is that same plot overlaid onto a Google Map image, and you can begin to see the terrain and what the coverage is going to look like. But ultimately, what I want is all built in within DragonOS, so you'll be able to generate your RF coverage map, and then you'll be able to open up another application, excuse me, right directly in DragonOS that's going to do a lot of other things too, like your direction finding on DF Aggregator, or maybe other survey results, but also allow the ability to upload and view the coverage map that you just created. And then we'll probably look at ways to make this maybe a little more like transparent, so you can see through the actual image and the terrain underneath. So that's the goal of that, and I think that this is would be a really powerful tool within DragonOS. We're always taking a look at software-defined radios and what that provides you in terms of looking at all the signals around you. Now you'll be able to plot out and visualize what those transmitters are doing that you may be receiving, or if you are, for example, I guess a ham operator, and you're transmitting, or you're setting up your antenna or transmitter, you'll be able to see kind of the effect or characteristics of your transmitter. So to make all this possible, though, there's something kind of behind the scenes here that's happening, and you have to provide a signal server with elevation data. So there's many different places out there, but I came across this site called Panoramas.org, and what this allowed me to do was come down here and look for the digital elevation models. I clicked on that, and I could see that all these locations, in particular I was looking at North America, are available in the type of data that is needed, which SRTM data in the HGT format. Okay, and I'll put some links in the description where you can read more about what SRTM is. But for signal server, you can use SRTM 3 and 1, I believe. And so I came here to North America. I clicked on World Coverage Map, and what this allowed was the ability to click just a particular area of interest. And once you did that, you could download that zip file, but I'll just go ahead and open it as an example here. And once that downloads, while that's downloading, I'll just kind of show something else that I've done here. So there was another site that I found, SRTM, this, just a random site that I found that had SRTM data, and I downloaded, it was probably a couple gigs worth of zip files that I just did a wget recursive, and these zip files, right, are what I'm looking for, which now that download finished, you could see how this would be really helpful, because it only pulls down the .hgt files for the location that's needed. So that's going to be pretty handy there when you're trying to get the data just for the particular area that you need. And that was all from this website here. But so once you get that data, there's a script, and this, so I know that I'm all over the place right now, but in the user source signal server folder, I've got a hold of some scripts here. One in particular called let's see, this get tiles, which a gentleman had put together. I just altered it. You can see the gentleman's name up here, this SRTM to SDF processing script. So I just changed some settings here to where my signal server, or where signal server is sitting at, and the destination really is all I cared about. But I blanked out most of it, because really all I was interested in was the scripted out part of unzipping files and renaming files, and then of most interest was the converting files. So I told it to use the signal server folder, utility folder, and a particular tool to convert these files from the .hgt structure to, and if I come here to the user source SDF folder, converts it, and it'll ultimately end up looking like this. Probably could take it one step further and zip these files up individually, and my understanding is Signal Server would still read those, but this is just the raw file itself, and it has to be sitting in user source SDF for this to work. So we'll figure out something how to make that a little easier in the future. But anyways, you can see how this will make this this particular site would make this a lot easier. But key is getting the map data. All right, so let's see. What else can we talk about? So we've got a plot that we've did for this TV tower KW test I just put in here. So let's take a quick look at enrolling a new tower here. I'm just going to call it KC test, and let's see. I've got a page pulled up here where I just was looking up some different TV towers in Denver, and this KCEC, we can just do a quick check here, and we can find the wiki page for this KCEC. We could come down, we can get its transmitter locations here, the ERP, and the antenna height and feet. And so let's see, I'll take that information, I'll do, let's see, and we'd put this in here, and we'd get that data into the database. So then we'll come over here and we'll do a KW test. We're going to do a profile between two stations. So I'd select each one, and I'd come down through, and what we're going to do is a line of sight between the two here. And we'll just change the frequency to, let's see, we'll go 590. And okay. And we'll create a plot between the two. So now you can see we get this profile antenna graph distance up here that will help us understand an analysis between the two locations. So if we scroll down, we can see the transmitter site, the transmitter, and the receiver, the elevation and distance between the two. So it looks like just a little over 4 miles, and the azimuth, and then we can get some additional information as we go down through here to understand the line of sight characteristics between the two, based on some and this is why I was saying that if you use Signal Server via command line, you can change some things like the radio climate, polarization, atmospheric conditions, and get really complex there. But you see your free space path loss, computed path loss, and then it basically tells you, hey, no obstructions to line of sight path due to terrain were detected. So this is going to be a really powerful set of software tools in here to get you some information through open source. So all right, I think I covered pretty much everything I wanted to cover. In the next video, I'll try and put together, we'll get a little more detailed, and hopefully by then this will all be included. In the meantime, I'm still working out a Raspberry Pi version of DragonOS that does include the desktop and many more tools. So be pretty busy. but just wanted to kind of give a preview of what's being worked on. All right, thank you.